Okay, so I've had requests, at least two different people have said, do we have to use Java? I want to use C Sharp, I want to use Python. And I wonder why you have these requests, and it may have to do with the UI. Okay? That many of you, I asked you, how many of you use AWT or Swing, and only two or three people raised your hand. And that is stuff that's actually taught in Comp 101. I mean, you look at Comp 101 textbooks, and they'll have how to create these little GUIs. But it's a mess, and if you don't understand the theory behind that, just maybe Googling also is an issue. So I'm going to, my first two lectures are going, first three slide decks are going to be on how to build an interactive application. I'll try to teach you the theory behind this, and then it'll be details, and surely you can master those. Okay? So let's go and say, and this makes sense because we're going to create multi-user applications, and just as your first assignment is going to take you to the first step of creating a single user application, our theory also will begin with first single user application, see if there is some theory there, and then go to multi-users. Okay, so what does an interactive application look like, really? What is the architecture of it? What is the anatomy? Okay. And let's go and take a very simple example of this Echo tool. This is a little different from what I demoed. So we are just, this Echo tool, we are not using a GUI, we are using a console-based user interface. And it's prompting you for new lines to echo. And it displays an arbitrary number of messages. So what you can do is you can enter an arbitrary number of messages. At some point you can say history. It'll give you the list of messages you've entered. And then you can say quit. Okay, this is the kind of stuff you will do in Comp 101 in pretty much the first 2 or 3 weeks. Okay, and let me just show you an implementation. And we'll try to see why this Comp 101 implementation is not a good idea. It seems okay, but I've named it such that I've used a bad adjective for the implementation, monolithic. So it must mean that there's something wrong, that I haven't decomposed it well. But what I'm doing seems obvious. I go in a loop, and I look at the next line, the user's input, and if it's quit or history, I do the quit or history command. Otherwise, I go and enter the message into a history object. And this history object is right here. It's an array list. Okay, it's a list. So this is if I was to give you no constraints, give you no lecture, you'll probably go and implement this particular code this way. Okay, and to understand some principles in building interactive applications, what's wrong with this? Everything is in one class. Okay, it's in different methods. Okay. And so I'm saying everything is in one class, it's monolithic. That's not a good idea. We know that in object-oriented programming, creating multiple classes seems like a good idea. Yes, in many situations it is. But in this example, in an interactive application like this, is there any other way to really do this? That's better in some way? So the data model is, what is data model here? History. And the UI is here. So this is data. This is UI. You see the UI code is far bigger than the data code, right? What do you guys think in general? What's the relationship between the UI code and the computation code? 50-50, 20-80, 80-20? 90 is user interface, 10 is, in many applications it is, but they've done surveys across applications and it's about 50-50. Okay. They've done surveys with console-based user interfaces, with GUIs, and various kinds of surveys. But it's a substantial thing, GUI. Okay. So in principle, the data and UI are in one program, so that seems like a bad idea. But in practice, I mean, in this particular case, is there a problem with that? So two things should not be kept in one class if, how do you decide on how to go in, Yannick?
If they have different responsibilities?
If they have different responsibilities, but you can think of any piece of code that can be decomposed into subunits. If the subunits would have different responsibilities, right? So as long as I have two different procedures in a class, I'll have two pieces of code that have different responsibilities, yet I keep them in one class, right? So that have different responsibilities. That's a necessary, but not. That's a sufficient condition. No, that's neither necessary nor sufficient, right? Actually, that's necessary. It's not sufficient. What other constraint do you want to put on it? So if two methods in one class, they have different responsibilities. One is a get, the other is a set. But we put them in the same class. Yeah.
If one can be unaware of the other, then they should be separated.
If one is unaware of the other, so does the setter have to know about the getter?
Okay, well, I guess with the setter and the getter, though, is that they are both aware of the same underlying property.
Okay. So you're getting towards that. Let's go to this data UI thing. Maybe that'll help you answer. What's wrong with keeping data and UI in the same program? Yeah.
You have multiple UIs referring to the same data.
You could have multiple UIs referring to the same data. Okay. So the UI and data in both one class. Okay, and we see here, there's two different ways to go and enter echo strings. Okay, so a single user. This is very important. You know, you hear me talking a lot about this UI competition separation. It's because I come from collaboration background. Okay, in a single user case, you may or may not have multiple user interfaces. Okay, actually, you typically do. Okay, but when you have multiple users, it's more likely to have multiple user interfaces for the same data. Unless every user is seeing the same state, that when I scroll, you scroll, and so forth, there's going to be two different states, two different user interfaces accessing a common data object. Okay? So collaboration tends to provide a stronger argument for data UI separation than not collaboration. Okay? Again, one can argue that even in a single user, multiple views are happen. Okay? So this is separation of concerns principle in software engineering that you might have heard of. And in this case, it means that you have history semantics and history display 1, same history semantics and history display 2, and you can change display without changing the other aspects of history. Okay? And that is the, so display and semantics should go in different classes. And that is the principle behind decomposition into classes. That if you have functionality A that can go with either B or B prime. Okay, so if you put if a class contains some functionality A and B, and B can change without changing A in another class, then might as well put A and B in different classes so that these two different classes can share some code, and only the B and B prime should be different. Okay, so this is the principle that we want to know. And so we are going to have the computation or data code in one class and the UI code in another class. And you know, there's no standard term for the UI. For the data, the standard term is model. Okay. For the data, it can be called interactor, which is what I'm going to use. You can call it editor, and some people just use the word view there. But that's a pattern we'll have. And those of you who've studied model view controller have seen a finer decomposition. And if you understand what that is, then the interactor is basically the MVC view plus the MVC controller. Okay? MVC also is defined in two different ways, one by Smalltalk, which invented it, and one by today's web technology people. And so I'm using the original MVC Smalltalk meaning here. And if you don't know what MVC is, forget it, because we're just going to talk about interactor and model. Okay? And that is something I want you guys to do in your first assignment. Okay? Not in the first part of the first assignment, just build the GUI, but in the second part, once you've mastered the GUI, have that architecture. Okay? And we'll see what kind of things you need to know to come up with the architecture properly. Okay? And then, of course, you know, you can have multiple user interfaces that are active at different times. So sometimes I'm viewing something through a text file, and sometimes I'm maybe viewing it in a graphical way. But you can also imagine having the user interface displayed at the same time. Okay? So I'm seeing the classic example from Smalltalk was I'm seeing a bar chart and a pie chart at the same time of some data. Okay. So then the question is, how do you make sure that when I make a change in one UI, the change is reflected in other UIs also? Okay. And any pattern quickly come to your mind at this point to make that happen? Okay, observer pattern. So you're going to make the interactor an observer of events or a listener. Okay, if you ever done any GUI programming, you say add action listener. A listener or observer are the same thing. Okay, and so the observer pattern is more general. Okay, there we are talking of some GUI element and some GUI listener. This we're talking of model and interactor. So the observer pattern is a sub pattern of this particular pattern I'm talking about, and you have an observable. And so change observable notifies observers in a sub pattern. So basically, whenever an observer changes, with observer are registered its with an observable are registered its observers, and whenever an observable changes, it notifies its observers. Okay, so if in this particular case, if a user enters some input, the interactor goes and invokes a method in the model to change it. And the model goes and announces its changes to everybody that's listening to it. So in this case, all the interactors are listening to the same model. And then they go and display output. Okay? And we see this, we'll see this pattern in this example here. So now I have this is my model. Okay? We don't have a monolithic program any longer. We have a separate model class. And the array list that I had in the original program is now encapsulated inside my model. Okay, and I have defined some special methods that send notifications. So this is my observer list. Okay, so not only do I have an array list of all the history elements, I also have an array list of all the observers. Okay, I have to keep track of all the observers. Okay, and now somebody who wants to make in this particular implementation, and you'll see that's useful. I can add without that add. There's an add that doesn't notify, and there's an add that notifies. Okay, the one that notifies is called observable add. Okay, and what it does is it does the regular add, and I should bring the pointer here. Okay, it does the regular add and then it notifies. And what do notifications do? They just go to the list of observers and tell them something interesting happened. Okay, so they just call this element added method in the observer. Okay, so this is again nothing complicated, something we do in 401. So the interesting thing here is that the model is unaware of the UI. The model doesn't know it's being displayed in a console interface or in a GUI or some other interface. It knows there are observers that want to know about elements being added, but doesn't know the details of these observers. Okay, so we want in software engineering to make components that are as less aware of other components as possible. Okay, and the model is about details of other components as possible. And here the model is unaware of. Here's my interactor, list interactor, and the interesting thing here is that the model is not built into the code as in the monolithic interface. It's supplied to it as an argument. Okay, so you can have multiple interactors sharing the same model. It's not as if a model is burnt into a particular interactor. Okay, that's very important. And you're entering input here. That's the process input. In process input, you go and change the model. Okay, you do an add. Then the change gets announced. This is your method for change announce, element added. And in that element added method, you go and display output. Okay, so you see this whole cycle in code here, that how the code that was all in one class, which is simple to understand, now is decomposed into multiple classes, which are harder to understand. But they provide you with the modularity we want. Okay, so this is why this particular part of the assignment is the second part and not the first part, because this is harder to do the first time. Then of course making a change is easy. Okay, so then the question becomes who created and connected the model and interactor. Somehow they had to be bound to each other, and the MVC. This particular pattern doesn't say anything about it, but in our implementation we have a composer that goes and creates a model, creates a view, creates the interactor and connects them together. Okay, so you see here the model being created, the interactor being created here, and then the interactor being registered with the model. Okay, and that's how this is all working together. Okay. By the way, this code is all the code I show in class is in a GitHub repository. And at the start of this slide deck, I actually give you the reference to that GitHub repository. So please, you can just, in fact, in your assignments, feel free to reuse the code, change it, whatever you want to do. You can't update the repository, but you can, of course, change your project. Okay. Okay. So in this example, I had an interactor who knows what its methods are. Okay. Besides the observer method, element added method, and I have a list with the add method for adding an element to the list, and size and get methods to get the size and the elements of the list. So I've put one method on the right and these two methods on the left. What property distinguishes these methods from this method? Okay, you.
So one of them is mutates the object, the other one doesn't.
Okay. So they are right methods and right methods. Okay. And why is that relevant in this architecture to distinguish between read methods and write methods? The notifications are sent by the write methods. Okay. The read methods you don't need to know if somebody accessed. Okay. So that's sort of describing the pattern in a more general way. Okay. So the general model pattern is that there's a model with some write methods and read methods, and the write methods send notifications. Okay. Now, we showed a picture with one model and multiple interactors associated with the model. The dual would be an interactor that has multiple models. Okay. And is that useful? You can imagine a UI showing, one UI showing multiple objects, tanks, human beings, and so forth. Each of them is a model, and it's the one UI that's keeping track of all of them. Okay, so there's nothing sacred about about how many models are connected to how many interactors. Okay, so that's the basic architecture that I want you guys to go towards. Okay, and to summarize what I said that when you have multi-view apps, then there's a certain architecture you want to go towards. And when you have multi-user apps, then multi-view apps becomes more likely. Okay, and the architecture you want to go towards should separate the UI code from the computation code. Okay, and the terms we use for these two pieces of code, a model and interactor. And within that, if you have multiple interactors being displayed simultaneously, then you want the observable subpattern within it, and a model can have multiple interactors, and an interactor can have multiple models. Okay. So those are the constraints. Okay. So now the lower level question is, what kind of interactors might I have? What are the differences between the various interactors? What kind of models might I have? Okay, and these are questions you might want to answer.